All right, so here's our practicum problem for tonight. We've got a lap joint between two pieces of material. The lap joint is over an area of 4 inches, and the plates are 8 inches wide. So in our first situation, we have the plates glued together. Shear stress is force divided by area. We're supporting a load of 25 kips. The area, if they're glued together, is the whole area of contact here, 4 inches by 8 inches. That would be 32 square inches. So we take that force of 25 kips and we divide it by 32 square inches, and we get 0.78125 kips per square inch, KSI. So a little bit less than one, a little more than 3/4 of a KSI, or about 781 pounds per square inch. Well, that's about the lowest stress we can get here, because that's about the biggest area of contact that we could use. In both of the other situations, we're going to have areas that are a lot smaller than that, so we're going to expect higher stress levels. In the second problem, we have the plates held together by two 3/8 inch diameter pins. So we've got two pins. We know they're circular because they say it's diameter, and each one is 3/8 of an inch in diameter. So best practice when you've got multiple things that you need to find the area of, they're all the same, find the area of one and then multiply by the number you've got. So the area of one of these would be the area of a circle, pi r squared, where the radius is half of that diameter. That'd be 3/16 of an inch. So we have pi times 3/16 of an inch. And if we run the numbers on that, 3/16, we square that and multiply it by pi, we get an area for one rivet or one pin of 0.11045 square inches. So the total area would be twice that, 2 times the area of one. So we'd multiply that by 2. So we have 0.11045 times 2. So we get 0.22090 square inches. Now the shear stress is force divided by area. So we've got our shear stress, that's force of 25 kips divided by an area of 0.22090 square inches. And according to the calculator, that's 113.17 KSI. Now that's getting up into stresses that I'd be worried about as far as the amount of load that that particular material could handle. These had better be some really, really strong pins if they're going to handle 113.17 kips per square inch. Typically 10s, 50 KSI is really pushing the limit. So I'd have to go back and consider whether this would be an acceptable solution based on the material that is being used. Then the last one here, we've got 10 1/8 inch diameter rivets. So a typical number of rivets that we might have in this kind of lap joint. So one of the most common rivets we use out there, the AD-4 rivet. That's our 1/8 inch diameter rivet. So let's find the area of one of those. It's going to be pi r squared. The radius is going to be 1/16 of an inch. So the area of one, we've got 1/16 squared times pi. So we get a pretty small area, 0.12272 square inches, but we've got 10 of them. So the area that we're dealing with is 10 times the area of 1. So that's easy enough. We have 0.12272 square inches. Smaller area than we had with the 2 pins, so might be worried about stress limitations here too. Might need more than 10, might need 20 or more rivets in this particular joint. So let's look at the shear stress. Shear stress is force divided by area. So we've got 25 kips divided by 0.12272 square inches. We've got 25.122.
Starting to go off the screen. You might want to push the
Oh,
page.
sorry about that there. It looks okay on my screen. But thank you for letting me know. Is that good there? Can you see it now?
Can just see right underneath the 0.12272.
Okay, I'm going to write off to the side here.
That'll be good.
So we divide that out, and we get 203.72 KSI. Can you see that okay?
Yep.
All right. So that's our answer there. That's pretty high. There aren't many materials with shear stresses up in that kind of range. So 10 rivets might not be enough. In fact, on Monday, we'll figure out how many rivets we really need in this particular joint. Any questions there?
Nope.
All right. Well, have a good night.
Yeah, you too.
Thank you.